Greetings and welcome to the homework solutions video for Chapter 7, Lesson 4, Day 2, Factoring Algebraic Expressions. As always, extra practice is right here if this is a skill that you would like to work on some more. And let's get into this. So factoring is basically undoing the distributive property. So we're trying to figure out what was our number that was outside the parentheses where we had a term either plus or minus another term. We have to figure out where did we come from. And to do that, we need to think about what are the factors, or what's the greatest common factor that we know of for each of the terms here. So I'm thinking here, we have 5 and we have 15. I know the factors of 5 are 1 and 5, and I know the factors of 15 are 1 and 15, and 3 and 5. So it looks like the greatest common factor that I can pull out is 5. And so now I'm thinking to myself, what something times 5 equals 5e? Or how did I get from something times something to 5e? So I know that this is the same as 5 times e, and I'm adding, and this 15 is really a 5 times 3. Now, if you notice, I put my factor 5 that I've pulled out, my common factor of both of those terms, I listed that first. And I did that on purpose because I want to then know this is basically saying that out front I had 5 that has been distributed to an e plus 3. And I could check myself where if I have 5 times e plus 3 and I go to use the distributive property, I would do 5 times e plus 5 times 3, and that is 5e plus 15. So if you notice, this answer here and that answer there matches. So this does check out, and we factored that expression. So your final answer is this right here, 5 times e plus 3. Remember, those parentheses are key. So for number 2, I'm thinking of my factors of 9 are 1 and 9, 3 times 3. My factors of 18, we have 1 and 18, 2 and 9, 3 and 6. So you might be tempted in this one to just pull out 3 because you know 3 times 3 equals 9. But if we're going to factor this in the most simple of forms, I know that the greatest common factor of both of these terms is 9. So I'm going to rewrite this, and I know this 9 is really a 9 times 1. And then we're subtracting here 9 groups of 2f because 9 times 2 equals 18. So if I undo that distribution, I've done a 9 times 1 minus 2f. And so you can see that this here with that operation and that second term are all what's left over if we pull that 9 out that we've distributed. And that is my correct answer. The trick on these ones becomes this 1. So knowing that you're not just going to get 9 times a negative 18f, because that would not get you a distributed form like that. So those ones can make it a little bit tricky. Question number 3. Let's do our greatest common factors. Now I am going to do the double ladder for this one just as a good review. So we have 21 and we have 18, and I know these both can be divided by 3. 21 divided by 3 is 7. 18 divided by 3 is 6. And 7 and 6, no more common factors, so that means this must be our greatest common factor. So I'm going to rewrite this with 3 times 7 plus 3 times, well, 6g. Now I know that I must have distributed a 3 to this term here of 7 plus 6g. And there's my answer. There are no other factors, common factors, for 7 and 6. So I'm going to do number 4. I'm going to do the double ladder for number 4 again because I think it shows really nicely. If you look here, this 7 shows up right there, and this 6 also shows up right there. And so using the double ladder can make it really easy on what do you need to do for your distributive property. So let's try that with this one. We have 30 and 15. I know these both can be divided by 5. 30 divided by 5 is 3. And these can both be divided by 3. And there are no more common factors for 2 and 1. So our greatest common factor is going to be right there, which is 5 times 3, or 15. So I'm going to rewrite this as 15 times 2h plus 15 times 1, which means 15 has been distributed. So that's not what I wanted to write with. 15 has been distributed to, I'll highlight these with blue, I guess, a 2h plus 1. So our answer is 15 times 2h plus 1. And this one seems a little bit tricky to me, so I am going to rewrite it. And I do want to check to see, how did I do? So when I use the distributive, I'm going to redo the distribution. 15 times 2h plus 15 times 1, 30h plus 15. And that matches, so this does check out. Question number 5. Do my double ladder. We have a 12 and we have a 20. So we can pull out a 2 and we're left with a 6 and a 10. We can pull out another 2, we're left with a 3 and a 5. 3 and 5 are both prime. So that means our greatest common factor is going to be here, which is 2 times 2, or 4. So we have 4 times 3m plus 4, not plus, this one actually is going to be minus, because that's our operation here. So we're going to be subtracting 4 groups of 5. That means 4 has been distributed to both of those terms, and the terms that we have left are 3m. Keep in mind, we are subtracting those groups, so 3m minus 5. There's our final answer. So let's look at number 6. And it looks like the terms are the same, but this operation here is different. So we're going to look and see, how does that affect this? I know that I can pull out a 4 again because we already solved that over there. So this is a 4 times 3m. Ooh, and our operation is addition, so we're going to be adding a 4 times 5. So again, note, we had to multiply by the same thing for each of those terms. So 4 has been distributed to a 3m plus 5. So the difference here is in question number 6, we have 3m plus 5 in the parentheses, but in number 5, we have 3m minus 5. So these directions are important. Use factoring to determine whether each pair of expressions is equivalent. If yes, show how you know that they are equivalent. If no, change one of the expressions to make them equivalent. And you can check yourself by using the distributive property after you factor the highlighted expression. So that means I could start, come on, little Apple Pencil. I could start by doing the distributive property here and then seeing, is that going to equal that? But this is a factoring lesson, so I'm actually going to start here and factor these. Now, I notice this 12m minus 20 is from up above. So I know from my work up above, I'm going to redo that real quick, where I know this is a 4 times 3m minus a 4 times 5, which means a 4 has been distributed to a 3m minus 5. So, are these equivalent? I would say not equivalent. So, to change it though, and to make them equivalent, I would change 12m minus 20 to 12m plus 20. And I know 12m plus 20 is a 4 times 3m plus a 4 times 5, which means 4 has been distributed to a 3m plus 5, and now they are equal. So let's check our factoring for number 8. I know, we have a 9 and we have a 9, so that means our greatest common factor is going to be 9. So 9 times n plus 9 times 1. That means a 9 has been distributed all the way across. So we have a 9 that's been distributed to an n plus 1. Ooh. Now I wonder though, let's see, what if I would have pulled out a 3? Because 3 is also a factor. So if I had done that, that would mean we would have had 3 groups, 3 times 3n plus 3 times 3. So that means this 3 here had been distributed to both terms. So we would have had 3 times 3n plus 3. And if you notice, this is really, really similar. This is very similar to our original. So in our original, we only had in our parentheses n plus 3, but here we have 3n plus 3. So these are not equivalent, but I think we could have made them equivalent if this one, let's see, the thing that was different, we need to change, we kind of have to change a lot in this one. I don't know if it's going to work to change very nicely. 3n plus 3. Let's do some distribution here. This is 3 times n plus 3 times 3, which is 3n plus 9. And so if we had changed this one to 3n plus 9, then they would be equivalent. So not equivalent, change to that. Awesome.